Hi, I am Mary Antonette. In this video, we are going to learn about one-sided limits. Here we see a sliding board and two children standing on either side of the sliding board. Now, as time approaches a point T from either side, we find that this boy has taken a different path from the left and has reached a different point. And the girl has taken a different path up the sliding board and has reached a different point. I think you would have guessed by now what one-sided limits are. Let us learn about one-sided limits in detail. This is the graph of f of x is equal to the greatest integer function of x. What is the greatest integer function? For example, if you have 2.33, the greatest integer is 2. If you have 1.22, the greatest integer is 1. If you have a number minus 1.77, then the greatest integer here is minus 1. And this is also called as a flow function where the real numbers are mapped to their greatest integers. We are now going to see how f of x behaves as x approaches 2 from the left. As x approaches 2 from the left, we find that f of x approaches the value 1. Now, this term of x approaching 2 from the left, we are going to represent it as 2 minus. Okay, x approaching 2 minus. So, limit x tending to 2 minus of f of x is equal to 1. 2 minus just indicates that x approaches 2 from the left. Similarly, we are going to see how f of x behaves as x approaches 2 from the right. As x approaches 2 from the right, f of x approaches the value 2. X approaching 2 plus is nothing but x approaches 2 from the right. Let us now look at the definition of one-sided limits. First, let us look at the left-hand limit or LHL. If as x approaches a point A from the left, f of x approaches a number L, then limit x tending to a minus of f of x is equal to L, where L is real. Now, a minus indicates that x approaches a from the left. Similarly, the right hand limit or RHL, if as x approaches a from the right, f of x approaches a number m, then limit x tending to a plus of f of x is equal to m, where m is real. Now, this a plus indicates that x approaches a from the right. Let us look at a few problems. Look at the graph and answer the following. Find limit x tending to 1 plus of f of x. What does limit x tending to 1 plus means? It means that x approaches 1 from the right. So, as x approaches 1 from the right, f of x approaches the value 3. So, the answer is 3. Next, find limit x tending to 1 minus of f of x. What is x tending to 1 minus? X approaches 1 from the left. So, as x approaches 1 from the left, f of x approaches the value 0. So, the answer is 0. Is limit x tending to 1 plus of f of x equal to limit x tending to 1 minus of f of x? We have seen that they are different. So, limit x tending to 1 plus of f of x is equal to 3, but limit x tending to 1 minus of f of x is equal to 0. So, the LHL and RHL are not equal. Let us look at another sum. Look at the graph. Which of the following are true and which are false? Limit x tending to 0 minus of f of x is equal to 2. Now, as x tends to 0 from the left, 0 minus means it tends to 0 from the left, f of x tends to the value 0. Therefore, the answer is false. What is the reason? Limit x tending to 0 minus of f of x is equal to 0. Limit x tending to 0 plus of f of x is equal to 2. Let's see if it is true or false. The limit x tending to 0 plus means x approaches 0 from the right And what value does f of x approach? It approaches the value 2. Therefore, the answer is true. Limit x tending to 1 minus of f of x is equal to 4. So, as x approaches 1 from the left, f of x approaches the value 4. Therefore, it is true. Limit x tending to 1 plus of f of x is equal to 5. So, as x approaches 1 from the right, f of x approaches the value 4. Therefore, the answer is false. And the reason is limit x tending to 1 plus of f of x is equal to 4. Limit x tending to 6 plus of f of x is equal to 6. Limit x tending to 6 plus means x tends to 6 from the right. And as x tends to 6 from the right, f of x approaches the value 5. Therefore, it is false. The reason is limit x tending to 6 plus of f of x is equal to 5. Limit x tending to 6 minus of f of x is equal to 4. Let's see if it's true or false. As x tends to 6 from the left, f of x tends to 4. Therefore, the answer is true. We are going to look at an alternate form for representing right hand limit. We have taken the same function f of x is equal to greatest integer function of x, and we have taken the difference x minus a is equal to h. Now, as x gets closer to a on the right, h gets closer to the value 0. We have taken h is equal to x minus a, or we can write x is equal to a plus h. In this graph, we know that a is equal to 2. So, limit x tending to 2 plus of f of x is equal to 3 can be written as limit h tending to 0 of f of 2 plus h is equal to 3. Now, we know that as x tends to 2 plus, h tends to 0. And when we write x in terms of h, we know that x is equal to 2 plus h. Therefore, instead of writing x tends to 2 plus of f of x is equal to 3, we have written limit h tends to 0 of f of 2 plus h is equal to 3. This is the alternate form. Now, if we take the general value a, so limit x tends to a plus of f of x is equal to m can be written as limit h tends to 0 of f of a plus h is equal to m. Now, let us look at the left hand limit. In this case, we have taken a minus x is equal to h because a is greater than x. We will see what happens to h as x gets closer and closer to a. As x gets closer to a, in this case a is equal to 2, h gets closer and closer to 0. So, we have taken here h is equal to a minus x. This implies that x is equal to a minus h. Here we have taken a is equal to 2. Here limit x tending to 2 minus of f of x is equal to 2 implies that limit h tending to 0 of f of 2 minus h is equal to 2. Because as x tends to 2 minus, h tends to 0, and in this case x is equal to a minus h, that is 2 minus h is equal to 2. So, generally limit x tending to a minus of f of x is equal to L can be written as limit h tending to 0 of f of a minus h is equal to L. Let us look at the second set of problems. Write limit x tending to 4 minus of f of x is equal to 7 in terms of limit h tending to 0. Limit x tending to 4 minus of f of x is equal to 7 can be written as limit h tending to 0 of f of, this 4 minus gets translated here. So, you have 4 minus and you have this h. So, I am including h. So, x can be written as 4 minus h. So, this is limit h tending to 0 of f of 4 minus h is equal to 7. The second sum. Write limit x tending to 3 plus of f of x is equal to minus 11 in terms of limit h tending to 0. Please try this out. So, we have limit extending to 3 plus of f of x is equal to minus 11 can be written as limit h tending to 0 of f of 3 plus h is equal to minus 11. So this is limit h tending to 0 of f of 3 plus h is equal to minus 11. Find limit extending to 2 minus of x plus 10. So limit extending to 2 minus of x plus 10 can be rewritten in the form of h tending to 0 as limit h tending to 0 of, in the place of x you can write it as 2 minus h. So you just have to include h to this and write x in terms of h. 2 minus h plus 10. So I have substituted the value 2 minus h in the place of 10. This is equal to limit h tending to 0 of 12. 10 plus 2 is 12 minus h. Now substitute the value of h is equal to 0 in this and you get the result as 12. Find limit extending to 2 plus of x plus 10. Limit extending to 2 plus of x plus 10 can be written as limit h tending to 0 of 2 plus h in the place of x plus 10. So which is equal to limit h tending to 0 of 12 plus h. Now when you substitute the value 0 in this, you get the answer 12. Find limit x tending to 3 plus of 2x squared minus 5 divided by x minus 2. So this is equal to limit h tending to 0 of 2. In the place of x you should write 3 plus h. So 2 into 3 plus h the whole squared minus 5 divided by, here again you have 3 plus h minus 2. Simplify this. Use the formula a plus b the whole squared here. And you get the value limit h tending to 0 of 18 plus 12h plus 2h squared minus 5, because I have multiplied this 2 with the bracket. And simplify this further. So you have 18 minus 5 is 13. All the others remain the same. Here again 3 minus 2 is 1 plus h. Now substitute the value h is equal to 0, because now we have reduced it to its lowest form. So when you substitute the value h is equal to 0, you get the value 13 by 1, which is 13. What happens when one-sided limits are equal? Let a be a point on the x-axis, let x be any point, and for f of x, let m be a point on the curve. So as x tends to a, f of x tends to m from the right. So this can be written as limit x tends to a plus of f of x is equal to m, and it can also be written as limit h tending to 0 of f of a plus h is equal to m. Similarly, from the left, you have a point x and a point L on f of x. Therefore, as x tends to a from the left, f of x tends to L. This can be written as limit x tending to a minus of f of x is equal to L, or it can also be written as limit h tending to 0 of f of a minus h is equal to L. Now when both these limits are equal, then the limit exists. That is, if the left hand limit and the right hand limit are equal to each other, then the limit exists. Here is an example. When x tends to 1 from the left as well as from the right, f of x tends to 2 along this curve. Therefore, limit x tending to 1 minus of f of x is equal to limit x tending to 1 plus of f of x is equal to 2. Here the limit exists. Let us look at the third set of problems. Let f of x is equal to 6 by x squared plus 9. Find limit x tending to 7 plus of f of x. So this can be rewritten as limit h tending to 0 of 6 by, in the place of x you should write 7 plus h the whole square plus 9. Simplify this using the formula a plus b the whole square. So you get limit h tending to 0 of 6 by 49 plus 14h plus h squared plus 9. This is equal to limit h tending to 0 of 6 by 49 plus 9 is 58 plus 14h plus h square. Now this is the lowest form, therefore substitute h is equal to 0 and you get the value 6 by 58. Find limit x tending to 7 minus of f of x. So limit x tending to 7 minus of 6 by x squared plus 9 is equal to limit h tending to 0 of 6 by 7 minus h the whole square plus 9. Apply the formula a minus b the whole square and you get limit h tending to 0 of 6 by 49 minus 14h plus h squared plus 9. Now add 49 and 9 and you get the value limit h tending to 0 of 6 by 58 minus 14h plus h squared. Now this is the lowest form. Now apply the value h is equal to 0 and you get the value 6 by 58. Check if the limit exists for f of x at x is equal to 7. Yes, you know that limit x tending to 7 plus of 6 by x squared plus 9 is equal to 6 by 58 and limit x tending to 7 minus of 6 by x squared plus 9 is equal to 6 by 58. Therefore, since the left hand limit and the right hand limit are equal, you have the limit exists. Second sum, let f of x is equal to 2x cube minus 1. Find limit x tending to half plus of f of x. So that is nothing but limit x tending to half plus of 2x cube minus 1 is equal to limit h tending to 0. It's always easier to convert it to h tending to 0 of 2 into half plus h the whole cube minus 1, which is equal to limit h tending to 0 of 2 into, when you expand this you get half cube that is 1 by 8 plus 3 into half square that is 3 by 4 into h plus 3 into half into h squared plus h cubed minus 1. Now when you multiply 2 with the bracket you get, simplifying this further, we get 1 by 4 minus 1 is minus 3 by 4. Now substitute the value h is equal to 0 and you get the value minus 3 by 4. This implies that limit x tending to half plus of 2x cube minus 1 is equal to minus 3 by 4. Find limit x tending to half minus of f of x. Limit x tending to half minus of 2x cube minus 1 can be written as limit h tending to 0 of 2 into, in the place of x you can write half minus h the whole cubed minus 1. So expand half minus h, you have half the whole cube that is 1 by 8 minus 3 into half the whole squared into h plus 3 into half into h square minus h cubed minus 1. Multiplying by 2 you get 2 into 1 by 8 is 1 by 4 minus 3 by 2h plus 3h squared minus 2h cubed minus 1. Now 1 by 4 minus 1 is equal to minus 3 by 4. Now since this is the final form, you can substitute h is equal to 0 and get the value minus 3 by 4. Therefore, limit x tending to half minus of 2x cube minus 1 is equal to minus 3 by 4. Check if the limit exists for f of x at x is equal to half. You know that limit extending to half plus of 2x cube minus 1 is equal to limit extending to half minus of 2x cube minus 1 is equal to minus 3 by 4. If you would like to receive regular updates about the classes, subscribe and hit the bell icon.